Now I already run my model and want to start to extract my results and check my model if it's correct or not correct. So first of all, you should go to what I told you last time, the model analysis. You go to this deformed shape and go to mode and start by first mode. You know the difference between different mode, right? I think 100, you don't know. So what you know?
No.
So when I have plan like this and I have frame like this. Okay, so this is a plan of any story of this. When I get vibration from the soil, what happened to the building? Building itself can go. If this is a building, so this building will go this side, for example, or it can go to this side, for example, and it can also rotate, and also in one direction. Should maybe it can behave like this, or it can behave like this. This one mode also can happen, and it can go like this, and it has a lot of modes, but each mode has mass participate for the model or has something can affect the model. For example, this one, which we can name it as a cantilever moon shape because it's like a cantilever. This take a lot of mass go in this side, but for this model or smooth, for example, it can happen, yeah, but a little or small part of the building go in this side, but a lot of mass in this building go in this moon shape. So if I submit or if I count this displacement, for example, with this displacement, you will find something like this. Yeah, it reduced a little because of this part, but it is still go in this side. And also for the software, I think you know the time period for the build. Yes. Here, for example, this acceleration, we already get it from something called T equal CH X here, and this is C and H. We can get it from the code depend on the system we use and all this stuff. So we should calculate this T, time period, and this T and the equivalent or the static method, we can calculate one number, but the software is very good in this part because for each mode it gives us time period. For example, this one time period equal, for example, 3 seconds. What's the meaning of 3 seconds? This one can, it was like this, it can go this and go this and get the same place in 3 seconds. Okay, and for example, for this one, which is very complicated, T equal 0.001. So it will be like, yeah, very fast. So this one will affect the model more than this one. This is what I want to say before. When I said most of this deformation or this model will take a lot from this more than this. Okay.
When you put mode number 2, does it mean it's going to combine both?
No. Mode number 2, second mode, which is for
Does
this.
it always combine all the modes or no?
No, not combine.
Because you were saying there when you add them together.
Yeah, not me. I don't add. Or the software added them in calculation of seismic load. Okay, not here, not in this partition.
Oh.
Okay, in the partition show you mode 1 alone, mode 2 alone, and that's it. Okay.
So mode 1 is always the worst.
Yeah, and we can't say like this because mode 1 maybe in one direction, and mode 2 in another direction, and yeah, mode 1 it will be if it's in this direction it will be the worst one. But for example, the fourth mode it will be like this. So it will be let's say, and you can see this. Yeah. We can activate the 3D here and apply. Yeah, no, not to start animation. It will take a lot of time. So here, yeah. Look here, we can. Oh, I can activate this option wire shadow to know if it's go to the side or the side. Yeah. Go to the side. Okay, and look about yeah, this one. This is the wire.
Oh,
the
that's the original.
the original one, and this the information, and look about the time period equal 5 seconds. So it is not 1 million seconds because of it. If it's like this, it is unstable. This is the first thing you should. Yeah, this is the last time I told you about this model analysis. If we go, for example, to model 2 or mode 2 here, it will be in another direction. Yeah. And the third one, last one we will show.
Oh, this is rotation.
Yeah. This is rotate. Okay. And the last one, force, and we will close this thing. Yeah. Go in the same direction, but with a little time period, and that's it. So this is the first thing you should check. And after this, look here, I told you there's something called mass participation. Each mode has mass to be counted in the total calculation of earthquake. So I want to know this mass participation for all modes I have, because there is standard in, or there is part in code saying you should, if you use the software to run your analysis, it should be at least 90% of your mass already active in your model. So to check this point, yeah, go to display, and this menu is very important for tool building. Show table. Yes. Here you can get your results on table instead of showing the value on graphical user interface. Here you can extract any table for anything you want. So here we will go to structure output and go for model information. And here there is something called model yes, this one, model participation mass ratio. Apply on this and go here for the selected load cases and choose earthquake X and Y, say OK, and say OK. You will get a table here. Yeah, this table. This table can show you, for example, I have model 1. And this model 1 happen in which direction? UX. Okay, so 171 of this mass of this building go in which direction? In X direction in this model. And the second one go to Y direction. What about the third one? No X, no Y. you will find here RZ. Look, guys, here we are caring about the horizontal seismic because we have two type of earthquake in X direction or in horizontal direction and in vertical direction. Vertical direction we should include it in our study if you have some members has limits like for example if you have beam with a very long length, so in this time you should apply the vertical seismic, but here we will use only horizontal direction. So for horizontal direction we are caring about UX and UY, UX and UY, and also the rotation about Z. So here we are caring about UX, UY, and RZ. So here you can see, or you can see here that UX 0.71, as I told you. What I'm caring here is the summation of these forces or this displacement. If you go down, you will find I have only 12 mode. You should go to summation of UX, this number. This number must be more than 90%. This standard. Okay, if it's less than this, what should I do? You should increase the mode. And when you increase the modes, in this time, your model take a lot of time to run your analysis. So it's like this. But it's not a big deal. It's a very small amount of time. But here, for example, you have only 12 mode, and you have 0.91 and here 0.89. You can accept this number. And also you should go to RZ and you will find it 0.93. So all of this number are good. But if you want to increase your modes, it's very easy. You can go to define and go to root cases. And here, model analysis, modify. Yeah, this one, maximum number of modes. You can change it, for example, from 12 to 20 and rerun again. There is no calculation will happen until you run your model again. But here, I'm satisfied with what I got. So now I checked the stability of the building and also the mass participation ratio.